Imagine a world where the temperature is hotter than the sun, where water, methane, carbon dioxide, and other molecules swirl in a dynamic atmosphere, and where two stars shine in the sky. This is VHS 1256b, a planetary mass object that orbits a binary system about 40 light-years away from Earth. So, what is the composition of the planet's atmosphere? What unique features set this newly discovered exoplanet apart from its celestial peers? Finally, and most importantly, what new and exciting features does this emission spectrum reveal that have eluded astronomers until now? In 2015, the JWST Telescope, developed by the UK, made a groundbreaking discovery by identifying a fascinating exoplanet known as VHS 1256b. This celestial object is a brown dwarf often referred to as a super-Jupiter because of its size similarity to Jupiter, but with an estimated mass up to 18 times greater. Initial observations suggested that this exoplanet had a reddish hue, which could indicate the presence of dust in its atmosphere. A recent study has confirmed the presence of dust in this brown dwarf's atmosphere, revealing intriguing insights into its composition. VHS 1256b is one of the closest brown dwarfs to Earth, located about 40 light-years away in the constellation of Corvus. What makes this exoplanet even more remarkable is it orbits a red dwarf stars named VHS 1256 and 1257 at a distance of approximately 440 astronomical units, or 440 times the distance between Earth and the Sun, taking a staggering 10,000 years to complete one orbit around its host stars. Red dwarf stars are a type of star that have low mass, low temperature, and low luminosity. They are the most common stars in the universe, making up about 3/4 of the stars in the Milky Way galaxy. The exoplanet's atmosphere is an exceptional and complex system that exhibits a variety of dynamic characteristics and phenomena. The James Webb Space Telescope has observed substantial temperature variations across the planet's surface, with temperatures ranging from approximately 900 Kelvin to 1400 Kelvin at different locations. This variability in temperature is due to several factors, including the planet's rotation, the uneven distribution of heat from its binary red dwarf stars, and the mixing of atmospheric gases. The fact that this exoplanet completes a full rotation in only 22 hours is a major contributing factor to the dynamic nature of its atmosphere. The planet's quick rotation causes atmospheric circulation, which results in the formation of powerful winds and storms. In March 2023, James Webb Space Telescope obtained the first direct spectrum of VHS 1256b, which separates the light from the object into its component wavelengths. The spectrum covers an unprecedented range of wavelengths from 1 to 20 microns and reveals a wealth of information about the atmosphere of this exoplanet. Upon analysis of its spectrum, water, methane, and carbon monoxide features have been detected, and evidence of carbon dioxide has also been found within the atmosphere. These molecules are common in gas giant planets and brown dwarfs, but their relative abundances can vary depending on the temperature, pressure, and chemistry of the atmosphere. One surprising result is that the methane features are not as strong as expected compared to similar objects. This suggests that there is vigorous mixing of the atmosphere and chemical reactions that deplete methane. Another interesting finding is that there are silicate clouds in the upper atmosphere. These clouds are made of tiny crystals of minerals like hot sand that condense in the atmosphere. The silicate clouds are detected by their effect on the spectrum. They block some of the light from deeper layers of the atmosphere and reflect some of the light from the stars. The clouds also cause variations in the brightness of VHS 1256b as it rotates every 22 hours. The clouds are likely driven by winds and convection in the atmosphere, which are influenced by the gravity and rotation. By studying the emission spectrum, astronomers found that the atmosphere of this exoplanet is remarkably rich in carbon and silicates. Silicates, which are minerals composed of silicon and oxygen, are commonly found on Earth as components of rocks and sand, but they are rarely observed in planetary atmospheres. Thanks to the powerful instruments on board the James Webb Space Telescope, astronomers have been able to detect the presence of silicate clouds in the upper layers of atmosphere. These clouds are formed when tiny particles of dust condense in the frigid temperatures of the planet's atmosphere, creating intricate patterns that change over time. The spectrum of VHS 1256b is the most detailed ever obtained for a planetary mass object outside our solar system. It provides a glimpse into the complex and dynamic atmosphere of a brown dwarf and demonstrates the capabilities of James Webb Space Telescope to explore the diversity of exoplanets. How likely is the James Webb Space Telescope, with its cutting-edge instruments, to detect signs of extraterrestrial life in the vast expanse of the universe? Share your thoughts in the comments section and let's explore the possibilities together. Thanks for watching.